Alright, let's consider the following problem. You're asked to find the pattern and then ask what's the 8th term. Alright, so just take a moment. These aren't on your notes. You don't need to write anything down. Just look at the problem with me. What do you notice about this pattern? What do you do to 0 to get 3? What do you do to 3 to get 6? 6 to get 9? And 9 to get 12? Well, hopefully you notice that you're going to add 3 each time. So what would our next term be if we continue on with this process? Alright, so our next term would be 12 plus 3 is 15. 15 plus 3 is 18. And 18 plus 3 is 21. Alright, so the 8th term, this is the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, and 8th term. So the 8th term would be 21. So this is kind of what we're going to be looking at in this lesson today. We're going to be looking at, this is called a sequence. Alright, so let's look at our definition. So these are on your notes now. A sequence is a function whose domain is a set of consecutive integers. If a domain is not specified, it is understood that the domain starts with 1. The value in the range are called the terms of the sequence. So our domain, 1st, 2nd, 3rd, 4th, all the way to the nth term, and our range, a sub 1, a sub 2, these are just going to be numbers. Okay? So a finite sequence has a limited number of terms. It has a limited domain and a limited range. Each domain value is going to correspond to a range value. And an infinite sequence continues without stopping. So like that dot, 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 it continues on. A sequence can be specified by an equation or rule. So for example, both sequences above can be described by the rule a sub n is equal to 2n, where n is the number of term. So for example, if I wanted the 3rd term, a sub 3, I would go 2 times 3 and it's 6. If I wanted the 100th term, I'd go 2 times 100 and it's going to be 200. So that's what we're going to be looking at today. We're going to be finding these rules. Alright, so a sequence is a list of numbers. A series, on the other hand, okay, when the terms of a sequence are added together and the resulting expression is a series. A series can be infinite or finite. Here's an example of a finite one, and here's an example of an infinite one, but you're just adding them together. So when you list the numbers as a sequence, when you add them together and you're going to get a resulting sum, then that is a series. So note, we can use what we call summation notation to write a series. This sum, this is my summation notation. This Greek letter sigma stands for sum. We're going to add them up. And in class, I'll show you how to use a calculator to do this also. So on your SOL, you're going to have the use of a calculator. Alright, let's practice some on the summation notation. So let's look at the following question. We want to find the sum from I equals 1 to 4. That's my domain. So my domain is going to go 1, 2, 3, 4. Draw yourself a little chart like this. Alright, my rule is 2i plus 2. And then we're going to add these up. So we're going to evaluate each one from 1 through 4. So this is a finite because it stops. Alright, so we're going to plug in 1. So 2 times 1 plus 2 is equal to 4. Now plug in 2. 2 times 2 plus 4, 2 times 2 plus 2 is equal to 6. 3. 2 times 3 plus 2, so that's going to equal to 8. And then put in 4. 2 times 4 plus 2, and that's going to equal to 10. Now you're not done on this until you add them up. So you're going to add 4 plus 6 plus 8 plus 10, and that final answer of 28 is your answer. So the sum of this is equal to 28. Okay? So these are my domains, 1, 2, 3, and 4. and my range is 4, 6, 8, and 10. Okay, so that's one thing is on your practice today, the summation notation. All right, now we're going to move into next. We're going to be defining the difference between an arithmetic and a geometric sequence. So write down the following. These are your definitions here. Arithmetic, you add or subtract a common difference. And in geometric, you multiply or divide a common ratio. So arithmetic, you add the same or subtract the same number each time. Geometric, you multiply or divide by the same number each time. So look at your pattern. So what do you do to 4 to get 7? 7 to get 10, 10 to get 13. If they all stay the same, then it could be either one of these. Now let's go back and look at this. What are we doing? 4 plus 3 gives you 7. 7 plus 3 gives you 10. 10 plus 3 gives you 13. All right, so this is going to be arithmetic, and my common difference is 3 because I'm adding 3 each time. All right, let's continue the pattern. So keep adding 3. Add 3 again, you're going to get 22. All right. All right, look at the second example. What's happening? What do we do to 27 to get 9? Well, we can multiply by 1/3. What do you do to 9 to get 3? Multiply by 1/3. So since that ratio stays the same, our common ratio is 1/3. This is geometric. All right, continue the pattern. So multiply 3 times 1/3, you get 1. 1 times 1/3, and 1/3 times 1/3. And our pattern can continue. It doesn't have to stop. But you need to know the difference between arithmetic and geometric, because those are the ones you're responsible for in this course. Okay? You'll talk about more in your next level of math courses. All right, what we're going to do today is we're going to focus on the arithmetic ones only today, and then geometric will come next time. Now, you do need to memorize these formulas. They will be given to you on the SOL, but because of the honors course and where you're going, your next level of math, I'm going to require you on our quizzing situations to memorize these following formulas. So here's the first one. All right, we're finding the rules of an arithmetic sequence. The nth term of the arithmetic sequence with the first term a sub 1 and a common difference of d is given by the following formula. So a sub 1 is the first term, n is the number of terms, and d is the common difference. We want to write a rule for the nth term of the sequence, and then we want to find the 19th term. So we're going to do two separate things here. We're finding the rule, and then we're going to find a specific term. All right, looking at our formula, we need the following piece of information each time. We need a sub 1, and we need to know what d is. What is our common difference? Well, in this case, this is a really simple example. It's already listed for, so my first term is 2. My common difference, I always want to take a latter term and subtract a previous term. So 9 minus 2, or 16 minus 9, or 23 minus 16. All right, but it's always a latter term minus the previous term. So my common difference is 7. So now I'm going to plug these values into this formula that you got memorized, and you're going to simplify it. So the nth term, a sub n, is equal to the first term plus n minus 1. I want to leave it in terms of n because I'm making a general form here, times my common difference of 7. All right, clean this up. So we're going to get a sub n. We're going to 2 plus, distribute your 7, 7n minus 7, and then combine like terms. So 7n minus 5. All right, and notice this is linear, right? And where's my common difference? It's the slope of this linear equation here, all right? It's a rule from the arithmetic, but it always ends up being linear. All right, so there's my first answer. There's my rule. This is my rule. All right, now let's find the 19th term. We're going to use our rule to find the 19th term. So we're going to go 7 times 19 minus 5. All right, do that math. Should get 128. So the 19th term is 128. So there's our second answer. All right, so we're just going to do a couple of different examples given different pieces of information. So I think this is the easiest one. We're going to get progressively got to find a little bit more. It's not really that hard. It's just arithmetic, but find different pieces of information each time. All right, example number 2. Finding the nth term of the arithmetic sequence. And you've got to tie the fact to the thing that you've got to memorize this particular formula. All right. Now, it tells me the 15th term is 107 and my common difference is 12. So I know my difference is 12, but now I don't have A1. So my first step is to find A sub 1. So I'm going to use this formula up here to find A sub 1. All right. I know my 15th term is 107. So we're going to plug 107 in for my term and 15 in for my n. And we're going to solve for A sub 1. And of course 12 is going to go in for D. Okay, so let's do that. So 107 is equal to A sub 1 plus 15 minus 1 times 12. All right, solve for A sub 1. So we're going to multiply 14 times 12 and subtract it from 107. So you should get A sub 1 is equal to negative 61. So negative 61. So now I've got what I need to make my rule. So now I'm going to make my rule and clean it up. So A sub n, because I want to write in terms of n, is equal to negative 61 plus n minus 1 times my difference. Notice I'm putting that difference in parentheses because if it's negative, you're going to have to put it in parentheses. So just get in the habit of putting that in parentheses. All right, let's clean this up. Let's distribute the 12 and then combine like terms. So your rule is going to be 12n minus 73. So that's my rule. All right, so let's finish the problem. It says find the 22nd term. So the 22nd term is going to equal to 12 times 22 minus 73. So the 22nd term is equal to, take a moment to do that math, I'm getting 191. All right, so just like I said, different information given to us, so we had to add a step to our process. Okay, so one more kind like this. Let's go look at another 2 terms of the arithmetic sequence are given. A sub 6 is 7, and the 22nd term is 87. Find the rule for the nth term. All right, notice here that we don't have either thing we need. We need A1 and we need D. We don't have anything we need, so we have to find both of them. Well, think about what D is. All right, D acts like what? This is linear, so D is your slope. So how do you find slope? Go back the other way. Let's find slope. It's the difference of the y's over the difference of the x's. So remember our domain. So our difference is going to be 87 minus 7 over my domain, which was with 22 minus 6. So this is going to get you what? 80 over 16, which is equal to 5. So my common difference is 5. All right, now we got to find A sub 1. Well, I've got my common difference, and I need one of the terms. I need either the 6th term or the 22nd term. It doesn't matter which one. I always tend to use the smaller term, so I'm going to use this one to find my answer. So 7 is equal to, and here again I'm using this formula up here, is equal to A1 plus my n is 6 minus 1 times the difference that I just found. All right, now we're solving for A1. So we're going to have 7 is equal to A sub 1 plus 5 times 5 is 25. Subtract 25, so A sub 1 is equal to negative 18. Negative 18. All right, so I've done all this work and I haven't even answered the question yet. We haven't found the nth term, the rule for the nth term. So now let's do our rule. Okay, so A sub n is equal to my first term plus n minus 1 times my common difference. All right, let's clean that up. A sub n, distribute my 5 and combine like terms. So there's my rule. Finally answered my question. Okay, so that's finding the rule of a sequence. The next couple formulas we're going to look at is when we have to find the sum of an arithmetic sequence. Alright, so here's the second formula you need to learn. So this formula here, maybe highlight it or put a box around it or something so you know what the formulas are you're responsible for. So we're finding the sum of a finite arithmetic series. We can never find the sum of an infinite arithmetic series. We can only do it for a finite one. So here's the formula. Make sure you understand what all of the pieces mean. So S sub n stands for the sum of how many terms you've got equals, so S sub n is the mean of the first and last terms multiplied by the number of terms. So a sub 1 is the first term, a sub n is the last term, and n is the number of terms in your finite series. So let's look at an example of this. We've got the following. So here, and you kind of have to be careful where this thing starts. It starts at 1, so my first term is a sub 1. This could start at 0, all right, and we'll do one of those in class. Okay, so we have to find my first term, a sub 1. So it's going to be 9 plus 3 times 1, which is equal to 12. My first term is 12. All right, my 15th term, because it goes from 1 to 15, my last term is the 15th term. So 9 plus 3 times 15 is equal to 54. That's my last term. All right, since this thing starts at 1 and ends at 15, there's 15 terms over 2 times my first term plus my second term. All right, do that arithmetic. Add 12 plus 54 times 15 divided by 2. And you will get to use a calculator on this section. So this is going to equal to 495. So the sum of my series is going to equal to 495. All right, so that's an example of using that formula. Let me show you one more formula and we'll be done with these notes. All right, look at the following. So here's the third formula you need to memorize. And these two formulas, the last two, do the same thing. They find the sum of a finite series. It just depends on what information that you have, depending on which formula you want to use. Okay, but you can be used interchangeably provided you have all the given information. All right, so what do we need for this formula? We need n, we need a sub 1, and we need our common difference to be able to plug in this. So an ordoterium has 25 rows, so my n is 25. So we want to find the sum of 25. The first row has 10 seats, so a sub 1 is 10. And each row after the first has one more seat than the row before it. So we're going to add 1 each time. So my common difference is 1. All right, find the total number of seats in the auditorium. Notice that I can't use the previous formula because I don't have what my last term would be. So that's why I want to use this formula instead. This one doesn't rely on the last term. All right, so let's just plug and chug into my formula. N is 25 over 2 times 2 times my first term, which is 10, plus n, which is 25, minus 1, times my common difference, which in this case is just 1. Okay? All right, so we just need to do the arithmetic. Let's start cleaning it up. So 25 over 2, 20 plus 24, which gives you 44. So 25 over 2 times 44, which is going to give you 550 seats in the auditorium. Okay, so that's arithmetic sequences and series. Like I said, you need to memorize those 3 formulas. All right, if you have any questions, please let me know and I'll talk about them in class.